Hello and welcome to this year's festive space adventure, No Place Like Home. Everyone you'll see during the show works here at Liverpool John Moores University in the Astrophysics Research Institute, and our jobs are to learn as much as we possibly can about space and the universe, and then to tell everyone all about what we found out. We have lots of space-themed learning resources that you can get involved with at the National Schools Observatory website. From here, you can also request your own observations from a real astronomy telescope, the Liverpool telescope in the Canary Islands. Teachers in the UK and Ireland can access everything for free, so make sure that you're registered. Today, we're going to be exploring the planets and moons of our own solar system in search of a good place to live. If your teacher or another adult has printed your pros and cons worksheet, have it ready along with a pen or pencil, and fill in the pros and cons for each location as we go. So now, on with the show.
Hi, hello, is anyone there?
Hello, can I help?
I'm not sure I'm in the right place. Me and my family are new to the area and we're looking for a place to live. Could you help us?
Well, this is the Astrophysics Research Institute at Liverpool John Moores University.
Oh, I thought this was an estate agent's office. You've got all these pictures of different places to live on the walls.
Oh, those are pictures of different places in space. Where were you living before?
Oh, quite a long way away. Have you ever heard of the constellation Ursa Major?
The Great Bear? Yes, of course.
Great, well, turn left from there, travel a few thousand light years, and that's where we were.
Wow, you've travelled a long way.
Yeah, unfortunately, the ice planet that we called home for many, many years is melting. So now we're looking for a new home in a new solar system, which is quite exciting, really. We really need your advice.
Well, now you are in the right place. We know all about space. I will get one of my colleagues to talk to you.
Hello, I hear you're looking for a new home in our solar system. What sort of place are you looking for?
Well, our last place was beautiful, so we would love somewhere with a great view.
Well, our solar system is full of wonderful sights, but for the best views, you can't beat Saturn. Saturn is a gas giant. It's the second largest planet in the solar system and has rings made up of ice and rocks. You'll get the best views of Saturn from one of its 82 moons. Let me show you Saturn's moon, Enceladus. Like Earth's moon, Enceladus always shows the same face to its planet. So if you choose the right spot, you will always have a view of Saturn and its rings.
Sounds perfect. What else is there to do there?
Well, you can explore the craters, the cracks and the boulders of Enceladus's icy surface. But watch out for the icy jets that erupt from the surface at 800 miles per hour. That's almost twice as fast as an aeroplane.
They sound like volcanoes, but ice volcanoes, what makes those?
Well, they are a bit like volcanoes. With an ice volcano, or cryovolcano as scientists call them, instead of a rocky surface, we have a solid icy one. And instead of hot magma escaping as lava, we have cold liquid. I'll show you what happens when an ice volcano erupts. But first, what is a volcano? Volcanoes are often cone-shaped, like a hill or a mountain. They have an opening in the top called a crater. There is a tube leading from deep underground up to the crater called a volcanic vent. Hot magma, ash and gas escape up through the vent out of the crater. In fact, the telescope we use, the Liverpool telescope, sits near a volcanic crater on the island of La Palma in the Canary Islands.
So what happens during a volcanic eruption?
Well, magma, a mixture of hot molten rock and gas, builds up beneath the surface. Pressure causes it to find paths up through cracks in the Earth's crust, and as it rises, gas in the magma expands rapidly, causing explosions. When magma erupts out of the volcano, it's called lava. On Earth, we usually find volcanoes along the boundaries of the Earth's tectonic plates. That is where the Earth's crust is the weakest.
But what about ice volcanoes?
Let's make a volcano and find out. You can do this at home, but make sure to get an adult to help you and stand back when it erupts, and make your volcano somewhere where you don't mind making a little bit of a mess. On the icy moon Enceladus, volcanoes contain stuff that is more like slush than magma. Here we have some solid ice, these packing pieces, some liquid ice, this water, and some gas, the air. And it's all inside this cup, which is our volcanic vent. All volcanoes need a source of heat. On Earth, that comes from plate tectonics. It's different on Enceladus. The gravity from Saturn and its surrounding moons pull and tug on Enceladus. This produces friction and heat, which warms up the icy liquid inside the moon and causes it to rise and expand. This small container is going to represent volcanic gas trapped underground. As this gas is heated, it rises, and as it gets near to the surface, it expands quickly and causes an explosive eruption. So we need to fill our container with gas that will expand rapidly. We are using a small amount of water and a fizzy tablet. We're going to add the tablet to the container, quickly put on the lid and add it to our volcano, and then watch what happens. The slushy magma exploded up through the surface, throwing ice and gas out into space.
Well, we like ice, but those volcanoes sound a bit scary. Is there anywhere else with a good view?
A good view, less ice. How about a small planet called Mercury?
Yeah, sounds promising. Can you tell me more about Mercury?
Well, Mercury is covered in craters, these round impact marks made when bits of space rock, probably from asteroids, hit the surface of the planet. You can see lots of these craters too on Earth's moon. I'll show you what I mean. You need a wide, shallow dish, a sieve, some flour, some cocoa powder, and a meteorite. If you don't have a meteorite, use a small rock, a small ball, or a marble. First, we'll make our rough, rocky surface of Mercury. Fill the dish with flour and sprinkle a thin layer of cocoa powder over the top using this sieve. This bit can get a little bit messy. We now drop our meteorite in. You can see that our impactor, the meteorite, made a nice crater. The rock has left this round hole, and it lets us see through the layers of the rock. We can look through the dark cocoa and into the white flour. The impact also left some of the white flour on top of the dark cocoa around the crater. We call these splashes of subsurface material rays. You can have a go at this experiment. There are lots of investigations you can try. Why not see what happens when you drop different sized balls, or balls made of different materials? You could also change the height or the angle on which you drop the ball from. Try measuring the depth and the width of the crater each time and see if you notice any patterns in your results.
So why are there so many craters on Mercury? It's covered in them.
Mercury has so many craters because it doesn't have an atmosphere to protect it. Earth's atmosphere actually stops a lot of meteorites from reaching the ground. They burn up in the air, and that's why we see meteors as shooting stars. One of Mercury's most impressive craters is the Caloris Basin. This is one of the largest craters in the solar system. It's more than 1,500 kilometres wide, so you could even fit the whole of the UK inside of it.
Sounds like there's a lot to see.
There is, and of course, Mercury is the nearest planet to the Sun. Therefore, you'll have the best view of the only star in our solar system. From Mercury, the Sun appears 3 times as big as it would on Earth.
From what I know, stars are quite bright, right?
You're right, they are. And from that distance, the Sun will be 7 times brighter than it is on Earth.
And stars give off a lot of heat.
That's right. The Sun's surface is about 6,000 degrees. And so because Mercury is so close to the Sun, daytime temperatures reach 430 degrees Celsius.
So that doesn't sound very good for people made of snow.
But at night, the temperatures reach minus 180 degrees. And because Mercury spins so slowly, nighttime on Mercury can last for up to 6 Earth months.
That sounds like a long time in the dark with no view. No, I don't think Mercury will do at all. What else have you got?
Well, I guess there's always Earth. We've got pretty great views there. We have lots of snow. And if you choose to live at the North or South Pole, you get beautiful views of the aurora. So even in the dark and in winter, there's still something to see.
Wow. So what makes those beautiful lights in the sky?
So the answer is a combination of Earth's magnetism and particles from the Sun. I'll show you. You might have played with a bar magnet or a magnet on the fridge, but did you know that Earth is a giant magnet? Magnets have a north and south pole, and they also have a magnetic field. This is the area around the magnet that acts on anything magnetic. It's like an invisible force field. You can see the shape of the magnetic field using a bar magnet and these tiny pieces of magnetic material called iron filings. We've placed the bar magnet on a piece of paper and covered it in a plastic sheet to protect it. Next, we shake iron filings over the top of the magnet. The filings arrange themselves almost magically in curved lines from the north to the south pole of the magnet. This is due to the magnetic field. The Earth is like a giant version of this bar magnet. It also has a magnetic field around it. So what has this got to do with aurora or northern lights? Well, solar storms on the sun's surface throw huge clouds of charged particles into space. The particles travel through space and some of these can reach Earth. Some of them are captured by the Earth's magnetic field and accelerate through the atmosphere towards the north and south poles. In the Earth's atmosphere, they collide with gases, and these reactions make a colourful glow. If the particles bump into oxygen, this makes a green or red light. If they bump into nitrogen, this creates a purple or blue glow.
I like the sound of Earth. It's a definite maybe. But could you show us what else you've got available in the solar system?
Of course. I'll go get one of my colleagues. I'm sure they'll have some alternatives for you.
Hello. I hear you're looking to live somewhere with a great view. How about a view of the largest planet in the solar system, Jupiter? It's twice as massive as all the other planets combined.
Wow, I think we passed that on our way through the solar system. Does it have a big red spot on it?
That's the one. Jupiter's great red spot is a giant storm in its clouds. It's been raging for 150 years, and it's twice the width of Earth.
Wow, that sounds like a bit too much weather. It must be windy.
Oh yes, the hurricane winds in the great red spot can travel at up to 400 miles per hour. To give you an idea of how fast that is, 75-mile-an-hour wind on Earth can blow over a large tree. But I wouldn't suggest living on Jupiter. It's a gas giant, so there isn't really a surface to build a home on. But, like Saturn, Jupiter has dozens of moons to choose from, and they have the best views of this beautiful planet.
Okay, I'm interested. Show me one of these moons.
I'd recommend Ganymede. It's Jupiter's biggest moon, so you'd have lots of space to choose from. In fact, it's the biggest moon in the solar system, even bigger than the planet Mercury.
Wow, I'm impressed. So we'd have great views of Jupiter. Is there anything else to do there?
Do you like swimming? Ganymede has an ocean that has more water in it than all of the oceans, rivers and lakes on Earth combined.
Ah, we don't usually do much swimming, but we could learn.
Then you'd probably better take up caving as well. The ocean's actually trapped below 150 kilometres of ice.
I'm not so keen on the sound of being underground. What else is there to do on the surface?
About half the surface is smooth and covered in craters. The rest is covered in ridges and grooves up to 700 metres high. That's 4 times higher than the Blackpool Tower. And these ridges stretch for thousands of kilometres.
Sounds like a bit of a maze. We might get lost, but I guess we could always shout for help.
Well, there's a very thin atmosphere, so your voice won't carry very far.
Oh, I didn't know you needed air for sound to work.
Sound waves are made by vibrations, but for vibrations to reach your ears, they have to have something to travel through, like the air. With no air, the sound can't reach your ears. Imagine you put your mobile phone in a glass jar and someone called you. You'd still be able to hear the phone because the sound waves travel through the air around your phone, out of the jar, and through the air to your ears. But what if you could remove the air in the jar using a special kind of vacuum? Now there is no air around the phone. No air means sound waves can't travel from your phone and out of the jar to your ears. The phone is ringing, but you can't hear it.
So no one could hear me on Ganymede if I get lost?
No, I'm afraid not. Much of space is what we call a vacuum. This means there is very little matter or particles, the stuff that makes up air, and everything else. Larger planets, like Earth, have enough gravity to hold on to their atmospheres. Smaller objects, like moons, aren't large enough to keep hold of much atmosphere. Ganymede's atmosphere is 100,000 million times thinner than Earth's. That's not enough atmosphere for our ears to be able to hear anything.
So that's not very good, really. Show me somewhere else, somewhere with more atmosphere.
If it's more atmosphere you're after, let me show you Venus. Venus is the second planet from the Sun. It's often called Earth's twin because it's about the same size and density, but there are a few big differences.
Like what?
Venus spins in the opposite direction to most other planets in the solar system. This means the Sun rises in the west and sets in the east. This is the opposite to all of the other planets, except for Uranus, which spins on its side. So that makes it pretty special. Plus, Venus has more volcanoes than any other planet in the solar system.
I like the idea of living somewhere special, but Venus is pretty close to the Sun. Does that make it quite hot?
Yes, Venus is the hottest planet in our solar system. The surface of Venus is hot enough to melt metal.
What makes it so hot?
Its thick atmosphere is mostly made of carbon dioxide. This is a greenhouse gas.
Oh, what's a greenhouse gas?
Greenhouse gases include carbon dioxide, methane, nitrous oxide, ozone, and water vapor. They trap heat. Let me show you. You need 2 see-through bottles or jars with lids, some water, 2 thermometers, some fizzy tablets, a heat lamp, and a timer. First, label one of the jars as greenhouse gas test. Then, put some water in each of the jars. Cover the top of the blank container with something. Carefully make a small hole in the top for the thermometer. Put the thermometer through the hole, but make sure it does not touch the water. Drop the fizzy tablets into the greenhouse gas container. As the tablets fizz, they release carbon dioxide. Quickly cover the opening and add the thermometer in the same way as before. Record the temperature of each container straight away. They should be about the same. The tablets don't add heat to the container. Turn on the heat lamp. Make sure the light is shining directly and evenly onto both containers. Observe and record the temperature. We can see that the temperature of the greenhouse container is higher. This is because of the carbon dioxide released by the fizzy tablets. This greenhouse gas traps the heat in the container and makes it harder for the heat to escape.
I'm not sure about living somewhere that feels like a greenhouse and is very hot. Is there anywhere to cool off on Venus? Maybe a sea to paddle in?
I'm afraid not. All the oceans on Venus boiled off a long time ago.
Wow. Okay. Is there anything else we should know?
The thick atmosphere is very heavy. The air pressure at the surface is much higher than on Earth, so it will crush you unless you wear a special protective suit. Spacecraft sent to Venus from Earth lasted less than half an hour before they broke up due to the heat and the pressure.
Is there anywhere to escape the heat, volcanoes and crushing pressure?
You could try living up in the clouds. The temperature gets cooler the higher up in the atmosphere you go, just like on Earth. Some scientists think that some kinds of life could survive high above the surface of Venus, although the clouds are made from volcanic gases like sulfuric acid, so probably it would just smell like rotten eggs.
Ooh, I don't think Venus is the place for us.
What about Earth?
We were shown Earth already, but I guess we could take a second look.
Earth has a great atmosphere, enough air for sound to travel through, but not enough to squash you.
None of those pesky greenhouse gases?
Actually, Earth does have greenhouse gases in its atmosphere, and they are important. Without them, Earth's heat would be lost to space, and it would be too cold for people, plants, and animals to live on. But luckily for us, Earth's atmosphere has much lower amounts of greenhouse gases than Venus.
Oh, okay. So if there was too much greenhouse gases in Earth's atmosphere, then it would also get too hot, like Venus?
That is true, and the amount has been rising over the last few hundred years.
But why?
Scientists think that it's been caused by burning fossil fuels, which provide humans with energy but also release greenhouse gases.
That does sound worrying. We're planning to live in our new home for a very long time. We don't want it to end up like Venus.
A lot of us on Earth feel the same way. We're already seeing changes in the Earth's climate. A lot of people are working on ways to make the way we live more sustainable in the future.
That does sound promising. But I don't think we've seen everywhere quite yet.
Okay, I'll find a colleague who can show you the rest of the solar system.
Hello, I hear you're looking for a new home in our solar system. Where have you seen so far?
Well, we've seen the moons of the gas giants Saturn and Jupiter, and the hot rocky planets Mercury and Venus, and Earth, of course.
Great, well there are still a few places left to look at. Let's start with the icy giants, Uranus and Neptune. These are the 7th and 8th planets in the solar system. Like the gas giants Jupiter and Saturn, Uranus and Neptune also have lots of moons as well as rings.
I hadn't noticed the rings. They're not as big as Saturn's rings. What else can you tell me?
Well, Uranus rotates east to west like Venus does, but it's also the only planet to spin on its side.
I think your colleague already told me that when we looked at Venus. But why is Uranus that pretty colour?
Uranus's atmosphere contains lots of methane, and that gives it that blue-green colour.
Ooh, methane's a greenhouse gas, right? Is it very warm on these icy giant planets?
Not at all. Because they're so far out in the solar system, Uranus and Neptune get very little heat from the sun. They're the coldest planets, but I'm assuming you don't mind the cold.
No, we don't mind the cold. But what else can you tell me about the climate?
Both Uranus and Neptune are very windy. The wind on Neptune can travel at 1,100 miles per hour. That's faster than the speed of sound and almost as fast as the top speed of a jet fighter plane.
It's also faster than the winds on Jupiter's giant red spot. These ice giants sound a bit too windy. They also look very dark.
Yes, they're dark because they are very far from the sun. The further from the sun, the weaker the light gets. I'll show you. These balls represent the planets. The lamp represents the sun. The distances between the planets in this model are not to scale. And remember that in reality, the planets of our solar system never fall in one straight line. We're going to measure how bright the light from the sun is at each planet using a light meter app on a phone. We put the phone next to each planet and point the screen towards the sun. The phone measures the amount of light, saves the data and plots it as a graph. The units are called lux. The number of lux tells us how intense the light is as it passes through the sensor on the phone. A higher number of lux is more intense or brighter. A lower number of lux is less intense or dimmer. You can see that the number of lux, or the brightness, gets lower and lower the further we get from the sun.
So how much darker is Neptune compared to your planet?
Well, Neptune is about 30 times further from the sun than the Earth. This means that sunshine is 900 times dimmer. Even the brightest time of day on Neptune would look like twilight on Earth.
I think we'd like somewhere a bit sunnier.
So, somewhere not too hot and sunny, but not too dark.
And somewhere with a good view.
Have you seen Mars yet?
No, let's have a look at Mars.
Mars is the 4th planet from the sun, and it is a rocky planet like Mercury, Venus and the Earth.
So where are the best views on Mars?
There is the Valles Marineris. This is a canyon 10 times bigger than Earth's Grand Canyon. Plus there is Olympus Mons, the largest extinct volcano in the solar system. So there is lots to look at.
What makes everything look so red then?
Well, it looks red because there's a lot of iron in the dusty rock on its surface. This reacts with oxygen in the atmosphere and rusts, causing everything to look red.
Is there anywhere on Mars to have a bath and wash off all the red dust?
I'm afraid not. We can see where rivers, lakes and oceans flowed on Mars millions of years ago, but today it's a dry desert.
But what happened to change it into a desert?
Well, we think that Mars's water evaporated into space. On Earth, evaporation is part of the water cycle. The water evaporates from the Earth to the atmosphere and falls back to the ground again as rain in a never-ending loop. Mars has lost most of its atmosphere over time. Without the atmosphere to keep hold of it, any water evaporated and was lost into space, although some did freeze beneath the surface. Let me show you. You need 2 see-through bottles or jars, one with a lid and one without, some water, a pen to draw a scale on the side of the jars, and some patience. First, draw the scale on each of your jars. Make sure that these are the same. Then, put the same amount of water in each of the jars. Place the lid on one of the jars to seal it closed. This lid will work like the atmosphere of a planet, keeping the water contained inside the jar. Now, place the jars on a windowsill. If they are in the sun or a warm room, the changes will happen faster. Just like on Earth, on sunny days we see more water evaporate. Record the level of water straight away. They should be the same. Keep watching the jars, checking the water levels a couple of times each day. We can see that the jar without the lid on, or the planet without an atmosphere, loses water over time. It evaporates into space. The longer you leave the experiment running, the bigger the difference you will see. The jar with the lid doesn't see the water level change with time. Sometimes the water gets lower as there is evaporation, but this is stopped from escaping by the lid. We then see condensation on the side of the jar. This water then falls back into the jar, keeping the levels the same. We see the same here on Earth. Water evaporates on sunny days and enters the atmosphere. It condenses into clouds and then falls back to Earth as rain, keeping the water on the planet.
It's a shame that Mars has lost all its rivers and lakes. I remember when we looked at Earth, there were plants, there were animals and people, and we're quite social, so we'd like to have neighbours to chat to. Would it be easy to make friends on Mars?
There might have once been life on Mars long ago, but if there was, it's long gone. As far as we know, there's no life on Mars today, so no chance of neighbours, I'm afraid.
Oh, that's disappointing.
Yeah, if you want friendly neighbours, Earth is your only option. It's the only place we know of which can support life.
That's yet another reason to live on Earth then. There's a lot to think about. That was a lot of information, but everybody seemed really helpful. I think I need to carefully consider the pros and cons of each place before I make a decision. And I need to let my family know what I've discovered.
Hi! How did it go?
I've been really busy looking for a new home for us, and I found lots of friendly and helpful experts at Liverpool John Moores University, and they've shown me around their solar system. But before I make a final decision, I wanted to let you know what I've learned. First, I looked at a place called Enceladus. This is one of the many moons of a planet called Saturn. Enceladus has beautiful views of Saturn and lots of ice to explore. But it also has icy volcanoes that erupt and blast ice and gas into space. So, it doesn't seem like a very relaxing place to live. Then I was shown Mercury. This is a small cratered planet close to their star, the Sun. In fact, it's a bit too close to the Sun. We'd have a great view of the solar system's only star, but Mercury is far too hot for us to live on. So, let me tell you about Jupiter next. Jupiter is a gas giant, so it doesn't have a solid surface to live on. But we could live on its giant moon, Ganymede. There's lots of opportunity to learn new hobbies on Ganymede, like swimming in its ocean and caving through its ice. But we wouldn't be able to talk to each other. That's because there isn't enough atmosphere for sound waves to travel to our ears. After Ganymede, I saw the planet Venus. This planet is unique in the solar system because it spins backwards. So we'd get sunrises and sunsets like nowhere else. But that's the only positive. The smelly atmosphere would crush us. There's no water, and it's far too hot because of the greenhouse gases. The ice giants, Uranus and Neptune, are nice and cold, as you'd expect from the name, but the weather is very windy, and it's just too dark because they're so far from the sun. Mars seems promising. It's sunny, there's beautiful scenery, but there's no running water, and there's just no life there. So, that leaves Earth. Earth's magnetic fields create beautiful light displays in the night sky. There's a good amount of sunshine and atmosphere, not too much and not too little, and there's loads of snow and water. Plus there's life, plants and animals and people to make friends with. The only downside seems to be the amount of greenhouse gases in the Earth's atmosphere, because they're increasing. This is changing the global climate, so it might not stay ideal for life forever. But the Earthlings seem to be working on a solution, and I think we can trust them. So, what do you think we should do? There's so much to think about. Where should we live? Okay, wonderful. We've made our decision. We're going to go and live on...
I hear you've come to a decision about where your new home will be.
Yes, we have. It was difficult though. There were a lot of places to choose from, all with pros and cons. Some, like Mercury and Venus, were too hot. Others, like Uranus and Neptune, were too cold. Ganymede was too quiet, and Enceladus was too wet. Mars was too dry.
So, where have you chosen?
We've chosen to move to Earth. It's got great views, a good amount of light, a nice climate, and most importantly, we will be able to make friends with our neighbours.
Wonderful. I just need to check, did my colleagues let you know about the potential changes in the area?
You mean the increased greenhouse gases and climate change?
Yes.
Yes, they did. But they also told us that people on Earth are working to make more sustainable choices so that Earth remains an ideal place to live. And we trust that Earthlings will do the right thing. Plus, we'll help.
Well, on behalf of everyone on Earth, welcome. I hope you enjoy your new home.
Thank you. I know we will.
That's the end of today's festive adventure. I hope you enjoyed it, and I'm very glad that the Snow family found a good home here on Earth. Before you go, we wanted to answer some questions about life in space that have been sent in by some of you in the audience. We've received lots of questions, so we'll try and answer as many as we can. Let's hear from some of our scientists. Our first question comes from Effie. Effie wants to know, how are other planets explored, and what information tells us whether there is life or not? I know who can answer that one. Let's give Chris a call.
Okay, hi Sean. Right, thanks for that question. That's a really interesting question. There's two different parts to this question, really, because we take a very different approach if we're searching in our solar system than we would if we're searching around other stars in the galaxy. So think of it like so I'll give you an analogy, an example. So my name is Chris Copperwheat. That's quite an unusual name, right? So if I was to search in the world for other Chris Copperwheats, I could do this two ways. I could walk to every house in my street and knock on the door and find out the name of someone who lives there. So I get a lot of detail that way, a lot of information, and I could verify with my eyes. I could check and see every person who lives in the house. Or I could search the entire world, and I could maybe search on the internet for my name and see if there are any other sort of people on the internet or on Facebook or Instagram or something like that. Right, so that's going to look at many more people, billions of people, 7 billion people in the world. But the search isn't going to be as deep. I won't get as much information because sometimes the information might be quite hard to find. And that's a bit like the two different ways of searching for life. So in the solar system, the planets and the moons of the solar system, we can actually visit them. So we send our probes to them, our spacecraft, our robots. They can land, they can measure with their instruments the content of the soil, they can look for life signs, they can look for signs of water. So we can really study it in a lot of detail, all the planets that are very close by. But they are very close by, right? So we're only looking at a tiny region of space. It's like me searching in my street, right, for people with the same name as me. So it's got probably quite a low chance of success. Okay. But then we can look at the entire galaxy. We look at stars that are very distant. So one of the first sort of widespread searches, there's been searches such as something called SETI, Search for Extraterrestrial Intelligence, where there's been searches for radio signals all over the sky. And that hasn't been very successful. That hasn't found anything that we've seen as a life sign, because perhaps it's a very wide search, but it's not very deep. It doesn't give us a lot of information. And the thing that's changed really in the past sort of 10, 20 or 30 years is we're starting to find the places in the galaxy where there's a greater chance of there being life. So we're finding planets around other stars. And now, most excitingly of all, with the latest generation of telescopes, things like the James Webb Space Telescope, which is NASA's new space telescope, as well as the large telescopes we're building on the ground, such as the European Extremely Large Telescope, we're looking at the atmospheres of those planets. So the gases all around us, the type of thing we breathe. Okay, so this is really interesting because not only are we searching for the types of gases that we have in our atmosphere, the things like oxygen and nitrogen, but we can also search for things that we call biomarkers, so evidence of life. So the oxygen in our atmosphere has not just come about on its own. It's the product of life. It's the product of the trees and the plant life we have on the Earth. So if I go back to my initial story, you might think, well, why do we bother looking at the planets like Mars and that sort of thing nearby if we're doing this big search and if there's no chance of us finding anything on Mars? Well, maybe it's not true that there's no chance of finding anything on Mars, because one of the things we don't know, one of the important things we don't know, is just how common life is in the universe. So you remember I told you my story where I would go to every house and look for someone who's got the same name as me, Chris Copperwheat, which is quite an unusual name. Well, maybe if instead I was to go to every house on my street and look for someone with a name that's John Smith, which is a much more common name in the UK. So lots of people in the UK have that name. So if I went to the 50 houses in my street, I've got a much greater chance of finding someone with that name. So the question is, how common is life? We don't know. We really don't know. We don't know what are the conditions to cause life to come from lifelessness. And it's only really when we understand that we'll know how common it is and where is the best place to search. So I hope that answers your question.
So next we have a question from Tarim Bhatti in class 5B in Lawrence Community Primary School. And Tarim asks, have there been any animals in space? Let's give Alison a call to answer that one.
Hi Sean, hi Tarim. That's a great question, thanks. Scientists have been sending animals into space for over 75 years now. The first were fruit flies. And when they returned from space unharmed, this made the scientists hopeful that humans could do the same. Other animals that have been sent up into space include apes, ants, bees, cats, cockroaches, dogs, fish, frogs, guinea pigs, mice, monkeys, newts, rabbits, tardigrades, tortoises, scorpions, silkworms, and even spiders. Today, the animals are sent into space to see how they adapt their normal behaviour to microgravity. When the animals take part in these experiments, the scientists really look after them. Their welfare is important. Thanks. Bye.
That was really interesting. So now we have another great question from class 5B at Lawrence Community Primary School. Daniel and Hawa ask, what are comets mostly made of and why does a comet glow? Let's ask Andy for this one.
Comets are actually made from quite normal stuff. They're made from ice. And some of it's ice like the ice you get in your freezer, ice made from water. But some of it is made from carbon dioxide ice. And carbon dioxide is the gas which makes fizzy drinks fizzy. But if you make that gas really, really cold, it turns solid and it turns into an ice as well. And so comets are a small ball of ice, water ice and carbon dioxide ice. And this could be quite important to us because we used to think that most of the water on the Earth, all the water in the oceans and all the water we drink, was brought to us by comets coming and smashing into the Earth billions of years ago. But actually, we now think that that's not the case because we sent a special satellite called Rosetta to a comet and it studied the comet really closely and it found that the kind of water that you find on comets is not exactly the same as the kind of water we get on the Earth. It's slightly different. And we now think it's more likely that most of the water on the Earth didn't come from comets, but from asteroids, from ice on the surface of asteroids that smashed into the Earth millions and billions of years ago. But actually, comets are quite difficult to see because the lump of ice is quite small. And most of the time, it's a really long way away, so far from the sun that we can't even spot it. But as that comet orbits around the sun, sometimes it gets really close to the sun. And when that happens, it's no longer cold. It starts to get really hot. And that means the ice on the surface turns from a solid into a gas and it makes a big cloud of gas that surrounds the comet. And that's shiny, that reflects lots of sunlight. And that's what we actually see as a comet, not the ball of ice in the center, but the shiny cloud of water and carbon dioxide vapor with the sunshine shining off it. And so what we think of as a comet is not really the center bit, but the big cloud of gas surrounding it that flows across our sky and gives us the beautiful comets that we sometimes see.
Thanks, that was great. So here's an interesting question from Kate. If we were looking at Earth from another galaxy, would it look habitable? Stacey can answer this one.
Okay, thanks, Sean. That's a really good question from Kate. So it's one of the most interesting things about space is that it is just so big that it takes time for the light, the thing that we use to see other objects in space, to reach us. Even our sun, so the closest star to us here on Earth, it still takes 8 minutes for the light to reach the Earth from the sun. So if we were sat at the sun, looking at the light being reflected back from the Earth, we would see the Earth as it was actually 8 minutes ago, not as it was in that very moment. And that's just within our own solar system. If we go to the next closest star, it's called Proxima Centauri. That star is just over 4 light years away. And what that means is it takes the light over 4 years to reach us from that star. So if we were sat on a planet orbiting around Proxima Centauri, looking back at the Earth and trying to figure out if life was on there, if life had evolved, we'd see life, we'd see the signs of life, we'd see the atmosphere, we'd see the technology that people had, but as it was 4 years ago, not as it was today. Now, that's the closest star, but space is enormous. And our one galaxy has over 100 billion stars in it. And if we were sitting at the other side of the Milky Way galaxy on one of the stars over there, looking back towards the Earth and the sun, it would take the light from us over 100,000 years to reach one of those stars. So if we were sat there looking at the Earth, if we had the best technology in the world and we could see the Earth in loads of detail, then we wouldn't be seeing it as it is today with the technology and the life that's evolved on it. We'd be seeing it as it was 100,000 years ago. That means no electricity, no internet, no towns or cities. It even means mammoths walking the Earth. We were in an ice age, and there wouldn't just be one kind of human species. Back then, there were still 4 kinds of humans. There was a human that we call kind of hobbit humans that were only like a meter tall. There was the first humans that stood upright. They started using tools and cooking. There were Neanderthals who were quite similar to our close ancestors, and our ancestors directly, which were Homo sapiens. So these evolved into modern humans, us today. And they're the only kind of human to survive. So if we were looking at the Earth and we could see it in all of its detail just from the other side of our galaxy, we'd actually be seeing not kind of intelligent life with technology and everything that we've got today, but we'd be seeing 4 different kinds of human species in the middle of an ice age who were cooking on fires, using tools, hunting for their food. But your question was about if we were on a different galaxy, and that was still talking about in our own galaxy. So let's move out of the Milky Way. Let's go to our closest big galaxy, which is called Andromeda. If we were sitting around one of the stars in Andromeda looking at the Earth, it would have taken the light reflected back from the sun 2.5 million years to reach us. So we're not just looking at the Earth with 4 different kinds of humans, we're looking at the Earth 2.5 million years ago, when humans were still around, but they were only just starting to even figure out how to use tools. So this is really early in human history. Now, Andromeda is our closest kind of big galaxy. We call it our local group. If we move outside of our local group of galaxies to one of the next closest, then we're looking at 6-7 million light years to get there. So if we were sitting in one of those galaxies looking back at the Earth, we're seeing as it was 6 or 7 million years ago. At this point, humans hadn't even evolved. Our ancestors at this point on Earth are gorillas. So there's still life there, but they certainly wouldn't be seeing life as we know it today. And the thing is that I'm talking about here only a tiny part of space. So if you've got aliens looking at the Earth from even further away, the Earth would look very, very different. As long as those aliens were sitting within 4 billion light years of the Earth, which is a decent fraction of the universe, then they'd probably be able to tell that the Earth had an atmosphere. And an atmosphere is a good indication that life could exist. But life on Earth back at that point would have been very primitive, maybe even just bacteria, depending on how far away they were. So if we were an alien on one of those galaxies with the best technology in the world, that we could see a planet that far away and see that it had an atmosphere, they'd have no idea that the life on that planet could evolve to be what it's become today.
I feel like I'm learning lots from this. So the next question is from Barira in 5M at St Lawrence Community Primary School. And they ask, how big is our sun compared to suns in other solar systems? Let's ask Kay Ryan.
That's a really good question. So our sun is quite unique in that in other solar systems there are some stars where they're giants, so they're much more massive than our sun, and there's some stars where they're supergiants, so they're even more massive. So they can be up to 1 million or 1 billion times more massive than our sun. And then there are some other solar systems where the sun is much smaller, so you have dwarf stars where the temperature is much cooler, and so that affects where life can form in other solar systems. So we are placed right in the center of the Goldilocks zone, where where the temperature is enough that liquid water can form and life can flourish. And so this will change when the star's mass changes, and so in other solar systems the Earth might be placed closer to the star and might be placed much further away than it is in our solar system. There are also lots of solar systems where there are multiple stars, so you can have 2, 3, 4 stars. And so if you're a fan of Star Wars, you can think back to Tatooine, where there's a sunset with 2 stars, so that will be similar to these solar systems where there's more than one star at the center. And so that just changes where this Goldilocks zone is and where life can form, so that's quite interesting.
The final question that we have time for comes from Lily in 5M at St Lawrence Community Primary School. Lily wants to know, what is the possibility of another solar system in our galaxy or another galaxy having a planet that, like ours, that could support life? And that's a great question, so I want to answer it myself. We know that there are lots of exoplanets. These are planets which orbit a star other than our sun. We've found over 5,000 so far, and we expect there to be billions just in the Milky Way. We tend to assume that the ingredients for life on other planets would be similar to the ones for life on Earth, like liquid water and organic chemicals, and we find these quite commonly. We don't think that there's any reason our galaxy would be special, so we expect that all of the billions of galaxies in the universe should have billions of planets and the ingredients for life. So it would be very strange if we were the only life out there. However, it's likely that the majority of any life would be microbes or bacteria, rather than intelligent life that could be capable of communicating with us. There's a formula for estimating the probability of there being a civilization which could send signals across space and communicate with us, called the Drake equation. And this is based on estimating how many stars there are, how many of these stars will have planets, how many of these planets could be habitable, and then the probability of life forming on a habitable world, the probability that this life could evolve to become intelligent, and the probability that this intelligent life would be capable of sending signals that would reach us for us to receive and interpret. And the period of a civilization when it could be capable of this kind of technology is very small in comparison to the whole lifetime of life on that planet we expect. Like, we've only been able to send signals like that on Earth in the past 100 years or so, when life has existed on Earth in the fossil record for over 3.5 billion years, and Earth has existed for 4.5 billion years. So if we put in our best guesses to the Drake equation, we get around 15 million planets that could be capable of hosting civilizations like this. But there are lots of estimates and assumptions in the Drake equation. So it could be anything from no other planets to many more than this. We just need to keep looking. Well, that's all we've got time for, I'm afraid. I hope that you had fun and learnt a lot from it. And thank you all for watching. Remember to register on the NSO and we'll see you soon. Goodbye.